Welcome back to the Deep Dive, where we cut through the noise and get straight to the knowledge. Today, we're delving into something pretty fundamental to Java programming, the new keyword. I've always sort of thought of it as just making an object. But I'm told there's actually a fascinating amount happening under the surface. What makes it so much more than just, well, a word? Our mission today is really to unpack the core purpose of new, explore how it truly functions behind the scenes, in the Java virtual machine, highlight its immense advantages, but also maybe shine a light on some potential pitfalls. Ultimately, we want to show you what all of this means for you as a developer, whether you're just starting out or maybe looking to deepen your Java understanding.
That's exactly right. We've pulled together various insights and explanations to give you a really comprehensive understanding. Our goal, as always, is to get through the complexity, get right to the most important nuggets of knowledge you need to be well-informed and confident.
Okay, great. So let's start with the absolute basics then. When you type new in Java, what's its core function? What's the fundamental definition we need to grasp?
Okay. At its heart, new is the core operator used to create an instance that's an object of a class, or alternatively, to allocate memory for an array. Without new, you simply can't create actual objects in Java. That's why it's just so essential for object-oriented programming.
Okay.
Think of it this way. A class is like a blueprint for a house,
Hmm.
right? It defines what the house will look like, how many rooms, where the doors go,
Yeah.
all that stuff. But without new, you only have the blueprint.
Hmm.
You don't have an actual concrete house you can live in or, interact with. New is what actually builds that house from the blueprint.
That house blueprint analogy really helps visualize it. That separation between the class, the plan, and the actual object. Our sources even suggest thinking of new as kind of a factory worker.
Yeah, I like that one.
Builds a new product, the object, based on the blueprint, the class. It really helps visualize that whole instantiation process. So, beyond just making an object, what are the primary purposes? Why is it so indispensable?
Well, first and foremost, it's for object creation. That's the big one.
Right.
It's how you get actual usable objects, like a string or, say, an array list. You literally can't use them until they're created with new.
Okay, makes sense.
Secondly, it's for array allocation. If you need a collection of data, but with a fixed size,
Mm,
maybe an array of integers or strings, new is what sets aside that specific block of memory for you.
got it. Fixed size.
Third, and this is critically important, is initialization. When you use new, it automatically triggers the class's constructor.
Ah, the constructor.
Exactly. And this is crucial because the constructor sets up the object's initial state. It makes sure it's ready to go from the moment it's, well, born.
So it's not just empty memory, it's set up.
Precisely.
Ah.
And finally, using new directly enables object-oriented programming, or OOP. It brings concepts like encapsulation, bundling data and methods together,
Hmm.
inheritance for reusing code, and polymorphism, treating different objects similarly. It brings those concepts to life by creating real functional instances you can actually work with.
So it's fundamental to how OOP even works in Java.
Absolutely. You'll find new indispensable in, well, countless scenarios: data structures, your own custom classes, framework components, or even just storing lists of data in arrays.
Okay, you mentioned new as a powerful operator, and that power must come from what it's doing behind the scenes, right?
Right.
What's the hidden complexity there? How does the JVM actually translate that simple keyword into a living object?
Right. It's actually a fascinating multi-step process inside the Java virtual machine. The JVM does quite a bit. The first step is memory allocation.
Okay.
When new is invoked, the JVM figures out how much memory the new object or array needs, and then it allocates that space on the heap. The heap, I've heard that term. Yeah, the heap is a specific region of memory used for dynamic allocation, meaning memory that's managed during the program's runtime, not fixed at compile time. For objects, this allocated space includes room for all its fields, its instance variables.
Okay.
For arrays, it's space for all the elements you specified in the size.
Gotcha. So space first. What's next?
Next comes constructor invocation. This is specifically for objects, not arrays.
Right.
If you're creating an object, new then explicitly calls the class's constructor. This is where the object's fields get initialized, like I mentioned.
And what if I didn't write a constructor?
Good question. If you haven't defined a constructor in your class, Java provides a default no-argument constructor. That gets used automatically.
Ah, okay. Convenient.
Very. Then, once the memory is allocated and the constructor has run for objects, new performs a reference return. It gives you back a reference. Think of it like a memory address, basically. A pointer to where that new object or array lives on the heap.
And that's what I store in my variable.
Exactly. You typically store this reference in a variable, so your program knows where to find and use the object or array. There's also something called class loading. It's
Yeah.
worth noting.
Right.
If the class you're trying to instantiate the blueprint hasn't been loaded into memory yet, the JVM will load it via the class loader before even starting the object creation process. This makes sure the blueprint is fully ready and understood by the JVM.
Makes sense. You need the plan before you build.
Precisely. And one of the really big benefits here, especially compared to older languages, is garbage collection integration. Objects created with new are managed by Java's automatic garbage collector.
Ah, the GC.
Yep. This means you, the developer, don't usually have to worry about manually reclaiming memory. The garbage collector automatically figures out when an object is no longer referenced, no longer reachable by your code, and it frees up that memory.
That sounds like a huge relief for developers.
Oh, it is. It prevents a whole category of memory leak bugs common in languages like C++, ENF.
So with new, doing all that work under the hood, allocating memory, calling constructors, handling class loading, integrating with the GC, it sounds like it handles a lot of complexities developers used to manage manually, right?
Absolutely. It simplifies a huge amount of low-level memory management. It abstracts away a lot of detail.
And for someone just starting out, could we maybe think of new as essentially just pressing a create button for the JVM? Like, okay, JVM, build me one of these.
Yes, that's a perfect way to visualize it for beginners. Thinking of new as a create button that tells the JVM to build, set up, and get a new object or array ready for use in your program. It hides all those intricate steps.
Okay, fantastic. Now we've talked about the what and the how, the definition and the mechanics. Let's maybe transition to the practical implications. While new is clearly fundamental, it's also important to understand its advantages and some common pitfalls, things that can trip up developers. What are the big wins when using new? Why is it good?
The advantages are pretty significant. First, there's explicit object creation, meaning when you see new in the code, it's unambiguous. It clearly communicates that a brand new object or array is being created right there. This makes your code's intent very obvious to anyone reading it.
Clarity. Okay.
Second, it offers incredible flexibility. New works with, well, virtually any class or array type. Standard library classes, your own custom classes, arrays of primitives, arrays of objects. It supports a vast range of programming needs. Very versatile.
Right.
Third, as we touched on, it's core to OOP. New directly enables those core principles: encapsulation, inheritance, polymorphism. It makes OOP work by creating the actual instances.
It brings the theory into practice.
Exactly. And finally, there's automatic initialization. For objects, new guarantees that fields are initialized via constructor. This provides a reliable and consistent way to set up an object's initial state, so you know it starts off valid.
Reliability and consistency. Got it. Okay, so those are the upsides. But
Yep.
here's where it gets really interesting, I think, because you know the saying, with great power comes great responsibility.
It applies here too.
What are some of the common problems or, let's say, considerations developers, especially beginners, might encounter when using new? It sounds like it's not always straightforward.
It's not always straightforward, no. One major concern is memory management risks.
Even with the garbage collector.
Yes, even with the GC. Since new allocates memory on the heap every time you call it, if you create objects excessively or unnecessarily, especially if you do it repeatedly inside loops, maybe creating a new object on every iteration when you don't need to,
Ah, okay.
that can lead to memory overuse. Your application consumes more and more RAM. This can cause performance issues, like more frequent garbage collection pauses, or in severe cases, even an out-of-memory error, which crashes your application.
Ouch. Okay, so be mindful of how often you use new.
Definitely. Another very, very common error involves null references.
The infamous null pointer exception.
Exactly. If an object variable is declared, but maybe never assigned an object created with new, or if it's created but then later explicitly set to null, then attempting to call a method or access a field on that variable will result in a null pointer exception.
Right, because there's no actual object there to work with.
Precisely.
Yeah.
It's probably the most common runtime exception in Java. Getting that first null pointer exception is almost a rite of passage for every Java developer.
I think I remember mine. Took ages to figure out.
We've all been there.
Yeah.
I remember spending hours debugging a seemingly simple piece of code once, only to find I'd forgotten to initialize an object variable after declaring it. Classic mistake.
So always initialize your variables properly after new.
Or at least check for null before using them. Then there's constructor dependency. New fundamentally relies on a class's constructor to do the initialization. If that constructor is poorly designed, maybe it's missing when one is needed with parameters, or maybe it throws exceptions that you don't handle properly,
Oh.
then the object creation itself, the new operation, can fail unexpectedly. This leads to runtime errors that might be hard to diagnose.
So the constructor has to be solid.
Absolutely. You also have to consider tight coupling. This is a bit more of an advanced design concern, but it's important.
Okay. What's tight coupling in this context?
When you use new directly inside a class to create an object of another specific class, you're creating a direct dependency. Class A knows it needs to create exactly class B.
Right.
This creates tight coupling. The two classes are strongly linked. It can make your code less flexible. What if you later want class A to use class C instead of class B? You have to change class A's code.
I see. It makes changes harder.
Exactly. Harder to change and often harder to test too, because you can't easily swap out class B for a test version, a mock object, for example.
So new gives you immediate power, but maybe at the cost of long-term flexibility, like building with super glue instead of Legos.
That's a great analogy. Yeah, good for a quick build, but a nightmare if you need to swap a piece later.
And this is where things like dependency injection come in.
Precisely. Modern frameworks like Spring heavily use dependency injection to manage object creation for you. Instead of class A using new to create class B, the framework injects an instance of B or something compatible into A. It decouples the classes.
Interesting. So new is powerful, but sometimes too direct for flexible designs.
It can be, yes. And finally, specifically regarding arrays, remember the array limitations. When using new for arrays, like new in 10, the size, and in this case, must be fixed up front.
Right, we mentioned that.
And
Yeah.
crucially, that size cannot be changed after the array is created. If you need more space, you have to create a whole new, larger array and copy the elements over.
Which can be inefficient.
It can be. This fixed size nature can be restrictive compared to dynamic collections like ArrayList, which can grow and shrink as needed.
So new for arrays is like ordering that custom fit suit once it's made. You can't easily change the size, whereas array list is more like adjustable sweatpants.
Exactly. ArrayList is much more adaptable and forgiving when you don't know the exact size beforehand or expect it to change.
Okay, that makes a lot of sense. So bringing this all together, what does all this mean for you, the listener, in your own coding journey? What are the really practical takeaways from our deep dive into the new keyword?
Well, I think our dive today shows that new isn't just about, syntax for creating an object. It's really the fundamental handshake with the JVM's memory management system. It's the silent orchestrator behind a lot of Java's power. And understanding what's happening under the hood, I think it shifts your perspective from just coding lines to actually building systems more effectively.
That's a great point. So beyond that higher level understanding, what's specific advice?
Okay, practical advice. First, use constructors properly. Always make sure your class has an appropriate constructor for initialization. Check the parameters it needs, if any, make it robust.
Right, don't neglect the constructor.
Second, be mindful of memory. Actively think about when and where you're creating objects. Avoid creating unnecessary ones, especially inside loops, to prevent memory waste and potential performance hits.
And use collections when needed.
Yes, exactly. When you need dynamic sizing, definitely lean on collections like ArrayList or HashMap instead of fixed size arrays created with new. Choose the right tool.
Okay. What else?
Third, and this is crucial for avoiding those common errors, handle nulls. After declaring a variable that will hold an object, make sure it gets assigned an object created with new before you use it. Or check for null explicitly before calling methods on it. Prevent those pesky null pointer exceptions.
Check before you wreck, basically.
Pretty much. Fourth, as you progress, explore alternatives for flexibility. Don't just stop at new. Learn about modern design patterns like dependency injection, factory patterns, especially if you start using frameworks like Spring or Jakarta EE. They offer powerful ways to improve testability and modularity, often by reducing direct new usage.
So understand new, but also know when not to use it directly.
Exactly. Also, test object initialization. Don't just assume your constructor works. Verify that objects created with new are actually initialized correctly, especially if your constructors have complex logic or might throw exceptions. Write unit tests for this.
Good point. Test the setup.
Remember the fixed-size nature of arrays created with new. Understand when an array is appropriate and when you really should opt for more flexible data storage, like a list or map.
Choose the right data structure.
Yep. And finally, probably the most important for beginners. Start simple. Don't try to build incredibly complex object hierarchies right away. Practice using new with basic, standard classes like string, date, or array list. And practice with simple arrays, like arrays of integers or booleans. Build familiarity and confidence before tackling more complex custom objects and their interactions.
That sounds like solid advice. Build that foundation first. Okay, we've covered a tremendous amount today, from the absolute basics of new and its intricate dance with the JVM to the crucial advantages it offers, but also the common pitfalls and considerations developers need to be aware of. This has been an incredibly insightful deep dive.
It has. And I think a main takeaway is that while new is undeniably fundamental to Java, really understanding its nuances, the mechanics, the implications, and the alternatives truly empowers you. It helps you write code that's not just functional, but also more robust, efficient, and flexible in the long run. Developing that critical thinking about where and how you create objects is really a key skill for any serious Java developer.
Absolutely. And maybe a final thought for our listeners to ponder. Think about how mastering a single, seemingly simple keyword like new doesn't just help you write lines of code. It fundamentally changes how you approach software design and problem solving. It opens doors to understanding more advanced patterns and architectures, like dependency injection or resource management. So what other foundational concepts, maybe things you use every day, might hold similar layers of depth just waiting to be explored?